Okay, today we're going to talk about how to do the particle size equivalent test, also known as PSEs to most of us in the brick business. This procedure is available not only on the Acme intranet, but also below the video on YouTube. There'll be a link directly to this procedure. So today, right here, we're going to talk about how to prepare the sample. That is actually not in this procedure, but it is as important to do before you actually do the actual test. So we're going to go through that right here. You basically will collect a sample of whatever material you're going to do the PSE on, and then you will place it in a dryer at 200 degrees, normally overnight. And once the sample is dry, take it out of the dryer. And usually most of your samples will look something like this, be somewhat chunky. And then we'll take it over to our hand grinder. And then you're going to run the sample through a hand grinder. Basically, you're going to want to end up with at least 50 grams, but normally you want a little bit more than that just in case. So once you've finished grinding your sample, this is what you're going to use to run the actual PSE. Okay, before we begin the actual PSE test, we're going to show the various equipment that you have to use throughout the testing process. First thing that you need to know is you always use distilled water throughout the whole process of the PSE. So what you see here, in no particular order, but you'll be using this in the whole process. A stopwatch to use to time for your readings, a little stopper here that you'll put on top of your graduated cylinder when you're shaking your material up. You've got a Celsius thermometer here, you've got a hydrometer to take your readings, you've got a scale to weigh up your samples, you've got the actual deflocculant, the sodium pyrophosphate in powdered form, and then here you've got your mixed up already deflocculant, which is 300 grams of powder to 1 gallon of distilled water. You've got your graduated cylinder, which you'll pour your sample in after it's mixed. You've got your standard Hamilton Beach commercial milkshake mixer with your milkshake cup, and then you've also got a squirt bottle that you will use to get the excess material out. When you pour it into the cylinder, there's always going to be some left in the bottom, and you use that to get it out. Again, always distilled water. Okay, the first thing you're going to do is take your milkshake cup and fill it up to there's two notches here. We fill it up to this first notch here, which is somewhere around 200, 250 milliliters, which is what it says in the procedure. Doesn't have to be exactly that. You're just looking for something approximate, because by the end of this, you're going to have 1,000 milliliters total. So you put that here. The next thing you're going to do is, this is the sample we ground up yesterday, and now we put it in a bag and given it a number. We're going to weigh up a 50 gram sample. If you see, our scale looks a little bit beat up, but it actually has been calibrated in the last year or so. So it's also important to know that when you get your scale, whatever you're going to use for the PSE, you need to make sure you calibrate it annually. So now we'll weigh up 50 grams here. So you're going to go over a little bit. You get better at it as you do more of it. So there, I dip a little out with a spoon. So we've got 50 grams here. Take the 50 gram sample, pour it gently into the distilled water here, tap it out, get everything out of there. And then the next step you're going to do is you're going to put your deflocculant in. So you get your bottle of deflocculant, take just a standard 250 milliliter plastic beaker or whatever you have, doesn't even have to be this. Pour a little bit in there. You're going to put 20 milliliters in there. We have a 12 milliliter syringe, so basically I'm going to put two sets of 10 milliliters in there. So go up to 10 milliliters. Poured it in there. Do another 10. Poured it in there. And now at this point, you wait a minimum of 15 minutes to allow the material to slake, and then we'll come back and mix it then. All right, so after a minimum of 15 minutes to let the sample slake, and now it's ready, we take the milkshake cup and put it on the mixer. It's going to mix for 5 minutes. Got my stopwatch here, so we'll put this on, and we'll start the time for 5 minutes. And in the meantime, during that time, you can get your materials ready for when the 5 minutes is up and you're going to take your reading. So you get your graduated cylinder ready. And make sure you have enough distilled water ready to fill up the cylinder. Make sure your squirt bottle's full, so you'll have enough to get out the excess. Have your hydrometer and your thermometer handy for when you're ready to take your reading. Got your stopwatch here to do your reading. It's important usually to have a couple of separate stopwatches, because if you don't, you're going to find yourself going back and forth. It's easier just to have one or two extras. That way you don't have to worry about mixing them up. Okay, so we're right about 5 minutes here. You take the sample off the milkshake mixer. Pour the sample from the cup into your 1,000 milliliter graduated cylinder. Take your squirt bottle, because you see you've got some leftover stuff in there. Use that to get the remaining stuff out. Do that, and then normally I'll try to do that. Get everything out of the cup. Give it one last little, so you've got everything out. Take your bottle here of distilled water. Pour that up to the 1,000 milliliter line here. Put your stopper on the top so it won't leak. Take this, turn it over. We're going to do this 3 times. 1,001, 1,002, 1,003. Let it go back. 1,001, 1,002, 1,003. Go back. Do it one more time. 1,001, 1,002, 1,003. This is when we go to take our reading. So put it down. Start your stopwatch. 40 seconds is going to be the reading. Take your hydrometer. Gently put it in here so that it doesn't bounce up and down. And now we're going to wait 40 seconds and we'll take the first hydrometer reading. And it's always good you have your thermometer handy. We have ours in the same cylinder here. Once you've got the reading here, then you'll take your thermometer, put it in there, and get your temperature. So we're at 35 seconds. So you look over here, you got your reading. This is an FSP material that doesn't have a lot of sand in it, so your reading is going to be very high. It's 49. So the time's up. So you record that. I'm going to take the hydrometer out and go ahead and put the thermometer in. Over on the sheet here, your 40-second reading. In this column right here, you're going to write 49. And then right next to it, you're going to have your 40-second temperature reading, which you just let the thermometer level out. Usually, your water temperature isn't going to vary that much. So it's 23.6. You want to do this in degrees C. So 23.6. And you're done with the first set of readings. So in exactly 2 hours from now, you will come back and do this exact same thing. Okay, following the first reading earlier in the video, I ran 2 others here, and that's why you see 3 cylinders sitting here. But 2 hours have gone by. So what you do for the second reading, take your stopwatch again, start it, put your hydrometer in again, gently so that it doesn't bounce up and down too much. And then you're going to wait 40 seconds for the reading, just like you did the first time. And then as you'll see, after following this, we'll just put the thermometer in there and get a reading on that as well. And then that'll complete the testing. All right, so we're getting right up at 40 seconds. Look at the reading, 10, 20, 30, 39. So that's your second temperature reading, or second hydrometer reading, 2 hours, 39. Your hydrometer, just put it back in the water. Put your thermometer in there. .0 is your second temperature reading, Celsius. And that's basically completes the PSE testing, and next we'll talk about the calculations. Yeah. Okay, now we're going to go through the calculations. Now we're going to do calculations on a different material that would be more related to what most of you would be doing at a plant, doing a body mix. The test that we did was more on a raw material. So we're just going to pick one out that we did recently. It's a material from the Denton plant. So your calculations here, we'll go through them real quick. First of all, we need to go by about what sand, silt, and clay are. PSE, particle size equivalent. So you've got 3 things that you're testing for: sand, silt, and clay. We regard sand as all the particles that are above 20 microns, and this little UM is just a symbol for microns. So it's your bigger particles. Your clay is your smallest particles. They're less than 2 microns. And the silt is kind of everything else. So it's anything that's in between 2 and 20 microns. So you've got 3 different things, sand, silt, and clay, and 3 different calculations that you use here. So we'll go through each one. And we're going to, like I said, we're just going to use the material that we went through in Denton. It's not really that important what these numbers are. This is just more to show you how to go through these calculations. So for example, the one we're going to do, the first hydrometer reading, which was the 42nd reading, the very original one was 39 here. So in this sand formula right here, H1 is hydrometer 1, so that's going to be 39. And then the first temperature reading, which is T1, was 24.3. And that's in degrees C. The second hydrometer reading for this particular material was 24. 24. And the second temperature reading was 24.4. 24.4. All right, so those are the 4 readings you took in doing this whole test. So now to do your calculations, as the procedure will tell you, you have to do it algebraically correct. So which means you go to the inside things first and do those, and then work your way out. So in this first formula right here, the first thing you do is what's in the parentheses here. So 24.3 minus 18 is going to be 6.3. So that whole thing right there is going to be 6.3. Then you're going to multiply that by 0.25. For that, I will get my calculator out here, and we'll do 6.3 times 0.25, which will be 1.6. So this whole thing right here is going to be 1.6. So then you add 39 to 1.6, so that gives you 40.6. So now this whole thing from here to here is 40.6. Then to finish this whole thing off right here, of course, you multiply it by 2. So 2 times 40.6 is 81.2. 81.2. So to get your percent sand, all this worked out to 81.2. So 100 minus 81.2 is going to give you 18.8 if my math is right. And that's right. So your percentage sand on this particular material is 18.8. Now, as you'll see, that's your most involved calculation, is the percent sand. This one is very similar, except you end up multiplying by 2 instead of subtracting. So here you've got, to do your percent clay, get your temperature here, 24.4 minus 18. That gives you 6.4 this time. And then, of course, 6.4 multiplied by 0.25 gives you 1.6, which is basically the same. And then your H2 reading was 24. Add that to 1.6. You get 25.6. And then multiply that by 2, and that'll give you 51.2. So that's your percent clay for this particular material. The percent silt is an easy one. It's basically whatever's left. So you got 100% as your total. You subtract the percent sand, which is 18.8. And then subtract your percent clay, which is 51.2. And that will give you silt of 100 minus 18.8 minus 51.2. That gives you 30. Exactly 30. And if you ever want to check to make sure you did it right, of course your three numbers need to add up to 100. So in this case, just looking at it, they do. 18.8 plus 51.2 plus 30 adds up to 100%. So this particular material, 51% clay, which is particle size less than 2 microns, 18.8% sand, which is particle size above 20 microns, 30% silt, which is in between 2 and 20 microns. Most of the folks, usually you can take these formulas and put them into a simple spreadsheet. That way you don't have to go through these calculations all the time. If you're going to do that, you just have to make sure that you get your brackets and parentheses correct. So what you want to do is take one like this, do it by hand, and then if you want to set up a spreadsheet, just use the same one and make sure when you plug your formulas in that you get the same numbers. Okay, and finally, there's a couple of things. If you look at the procedure that we have for the PSEs, at the very end, there's a section entitled Hints and Cautions. You can read through these at your leisure, but there's a couple of them that we need to emphasize. One, the distilled water, you need to make sure that it remains at room temperature. As you look there, here at the lab we have a large supply of it. Some of the plants you probably don't have this much. You want to make sure that you have enough to where you can get it to room temperature before you actually run the tests on there. If you're somewhere between 68 and 80 degrees, you're okay, but you don't want to be too warm, certainly, and without a doubt, you don't want to be too cold. So you always want to allow enough time for the water to get to room temperature. When you're doing your deflocculant, you want to make sure you pick a deflocculant or pick a company that you get the deflocculant from and stay with it, don't change. And if you ever have to change, like your supplier runs out or whatever, you want to make sure that whatever you switch over to, do some comparison tests on the same material to make sure that it's not going to affect your readings. I'm thinking you want to periodically also test your hydrometer to make sure that it's still working correctly, and the way to do that is to get a clean graduated cylinder, fill it up, and then put the hydrometer in there with just distilled water in there that's not contaminated at all with any residue from samples, and make sure that it ends up at 0. Those are the ones that are really super important. Again, take a look at the others that are in the procedure. Some of those are important as well, but those 3 right there are ones you really need to keep an eye on.